Okay, so welcome to this DCG video on 2022 question A4. Okay, the deferred exams. And the question is, okay, axonometric projection. Okay, so an incomplete, trimetric projection of the music speaker is shown using the axonometric axis method of a similar speaker is given. So trimetric means the triangle, the traces of the axonometric plane, is a scaling triangle, and the angles between the axes are all different. The plan is shown in its required position. Draw the elevation of the speaker in its correct position on the XY plane or vertical plane. Now, the last similar question to this would be 2009. So, as you can see here for the plan, the y-axis is extended to hit the semicircle. So here we're going to extend the z-axis. So I'm going to get my set square. I'm just going to extend the z-axis here until it pierces the semicircle. Now, then I can draw in, the edge of my end vertical plane. So I'm going to join. So I'm going to join where that continuation of the z-axis we just done, pierces the semicircle. So, and then I can bring it down here and join this end through, the end point of the diameter of the semicircle. And I join that pierce point to the end point of the diameter here. Now, this is an edge of our end vertical plane. And this is an edge of our horizontal plane. So the next thing we have to do now is project our points from our axonometric or trimetric projection of the speaker back parallel to the z-axis. So I'm going to project the top back here. Okay, this one is done. I'm going to bring the top right back. And I'm going to bring this back corner back as well. And then the base here. Now, next thing I can do is go parallel to the edge of the horizontal plane. So I can bring this here. And you can see where it strikes there. Now I can go down perpendicular to the horizontal plane there. There we go. Here's the top heavied in. And then this back edge here is going to project as hidden detail. And here's the bottom. Now, the next thing we're going to have to do is get the semicircle. So what we're going to do is we're going to draw an element, on through our center point. So an element is a line that's on the surface of an object. So I'm going to, and parallel lines are parallel in every orthographic view. So I'm going to draw a line parallel to the x-axis, through the center point of the circle. This is an element. So that's our element. Now we want to bring our element back towards our elevation. So this is where it touches here. Now I'm going to bring the center point back here as well. This element is parallel to the base here. So, it's going to be parallel to the base in elevation 2. I'm going to bring this up here, and this is our center point here. Okay, now all we need to do is get a point, okay, on the circumference of the circle. So at this point on the circumference of the circle, I'm going to get my compass, and I now have the radius. So I'm now going to draw it in here. Now, here's the elevation done. So the lovely part next here is determine the true shape of, okay, surface S. Right. Now there's multiple ways you could do it. Here's an edge view of surface S. So what we could do is project an auxiliary elevation from our plan view, okay, essentially. So I'm projecting perpendicular to the edge view of the face, so parallel to the end vertical plane. So I'm going to draw in an x1, y1 line. Now I'm going to take my height from elevation. I'm going to get this height here, step it on to this one here. Okay, and then I'm going to get this height here and step it on to this line here. Okay, and I can continue this up here. Continue this on here. And here's the true shape of surface S. An alternative way you could have done it is rotate the surface until it's parallel to the vertical plane. Alright, so you could have essentially extended this line in plan, put your compass, rotate this here onto the line, okay, bring a line parallel up here, parallel to the top. Okay, then get the distance here. So step it on to this one here. And then you'd be joining this back to here, and then you'd be drawn a line, okay, parallel to the side. And that's also our true shape there. Right, cheers, thank you, bye-bye.